So what we have here is it says if theta is this, find the theta dt at 2. Okay, so to theta dt ends up to be 6t. Multiply the 3 by the third, and you get 3t squared. You have t equals 2. You sub it in, and you get 12 minus 3t squared. 12 minus 12 equals 0. Okay. Same deal for the second question. You might be asked to do the VDR at r equals 5, and what you're going to get is you're going to multiply the 3 by the 4 over 3 because the r is the differentiable part. So it's going to be r cubed is the same thing as 3r squared when you differentiate it, and then you're going to multiply that by the 4 over 3, which is going to get you 4 pi r squared. You sub in your r equals 5, and that could be r equals 5 is going to be 25 multiplied by 4 pi, 100 pi. Okay guys, so now we have using the chain rule. A spherical snowball melts at the rate of 20 centimeters cubed per hour. Now that is a reduction in volume to respect the time, and it's going to be minus 20. So do you understand where I got the VDT from? The change in volume with respect to time. Okay? Then it goes, what is the rate of change when the radius is r? Okay? So what is the rate of change? So phi is 20 divided t. Alright, it's a divided t ends up to be dVdr by dr dt. Now, only reason I know to do that is the whole exercise this is in is about the chain rule. Okay, and I just remember the question. Okay, so dVdr over dr dt. What is it? And you see the way that dr's cancel, and it's basically dv dt equals dv dt. Okay. Now, what we have next, guys, is this. Okay, we have to find out what the VDR is. So phi is volume of a sphere is 4 over 3 pi r cubed. The VDR is the derivative of this. We just actually did it a second ago, didn't we? Differentiate, bring the 3 to the front, multiply by 4 over 3. You get 4. It's 4 pi r squared. Okay, so what we find is that your minus 20, which is the VDT, is equal to 4 pi r squared, and then what is the rate of change of the radius when the radius is 2? dr dt. Now, the rate of change of the radius is the change in the length of the radius. That's what dr means, the measurement in the change of the radius over the change in time. So what we're going to say is dr dt ends up to be minus 20. We're expecting the radius to get smaller, aren't we? As the snowball decreases, its radius is going to get smaller. Now we have to replace, that's our answer here. Are we happy enough with that? And now we have to replace r with 2. What happens when we replace r with 2? dr dt is going to be minus 20, 4 pi times, was it 2 squared? And somebody put that in the calculator for me, let me know what it is. Harder, is it? Yeah. So guys, what we have here is 20 over minus 20 over, what's it, 16 pi. Can somebody just give me that in decimals? Minus 0.39. Is it meters or what are we looking at here? Centimeters. And it's per hour, isn't it?
Minus 0.4, sorry.
Ah, okay. Yeah, rounds up. Okay, minus 0.4. Okay. Now, the next thing is find the rate of the change of the surface area. The rate of change of the surface area. So straight away, what that will do is it picks exactly what formula, it picks the formula for me is what we're trying to get at. Okay, it goes the rate of change. Rate of change means the t straight away. What is changing? The surface area. Perfect. Okay, and then what we want is that dA dt, and it's we have a formula for A. The surface area of a sphere is 4 pi r squared. automatically I know I can get dA dr straight away by differentiating into 8 pi r. So that's my dA dr part done there. And now I have my dr dt. Now it says find the rate of change to the surface area when the radius is 5. I need to find dr dt. We have the generic equation, don't we? The generic equation is minus 20 over 4 pi r squared. In this specific case, the radius is 5. So to get dr dt, we replace minus 20 times over 4 pi multiplied by 5 squared. Can somebody just give me that in decimal, please? Minus 20 over 4 pi 5 squared. Minus 0. 0.063. 6. Is that right? Minus 0.6. Okay. Well, one. Okay.
It's all about just swapping around. You can always get the formula over dt.
Yeah.
And then you just have to swap everything else around to get the other one.
Yeah. Metal cube time. Okay. Now let's see what the metal cube can do. Okay. A metallic cube of side length x. So once again, I'm visual, so I'll need to just draw myself a little cube for a minute, and then I know, yeah. So I always draw pictures to get the question into my head. Now, sorry. Okay. Now x, and x. Okay. And it goes. The side lengths are expanding at a rate of 0.2. The side lengths are expanding. They're getting bigger. Okay. So the lengths. What would we call the length? DL. Yeah, you can't do. Yeah, I think it'd be better just calling them L or DL. Yeah, because x is its value, not its actual what it actually is. So we call it.
They started getting out of contraction to find them, and then it was only drawn and stuff.
Okay, guys. So look, dl dt, okay, is the length is expanding by 0.2 centimeters per second. Okay. Find the rate at which the cube's surface area. Now, cube surface area is it's worth x squared on every face that it's length by width. Okay. And how many faces does it have? 6. So the area of the cube is 6x squared. Okay. Now find the rate at which the cube's surface area and the cube's volume are changing. So what's the volume then? Volume is x cubed. Okay. I don't like when that happens. X cubed, yeah. So at the moment we only have dl dt. Now I think that might actually have to change to dx dt in a second, because x is the length, isn't it? So it's what we taught, side length. So we're going to represent the length by x, okay? So it's dx dt, and find the it's increasing at 0.2. Find the rate at which the cube's surface area and the cube's volume are changing. Now we want dA dt. Is everybody happy with that? Yeah. Now to get dA dt, we have dx dt. Therefore, to complete this, we need dA over dx, and we can just differentiate this to find dA dx. What's dA dx going to be? 12x. So dA dt equals 12x, and then multiply by 0.2. What's the x value? 5. So 12 times 5 times 0.02, and the answer is 12, isn't it? Now get your units right. What is the units of area? 12 is a centimeters squared per second. Same deal with volume. dV dt is going to be, we have dx dt, no worries about that. We also need dV dx, and what happens when you differentiate volume? Sorry? 3x squared. Okay.
Good morning, here today's announcements.
Is this basically a question by two parts of it?
Okay, so guys, what we have next is dv dt equals dv dx over dx dt. dv dx is going to be 3x squared. dx dt is going to be 12. Therefore, dv dt is, we got to replace x with 5, isn't it? What's 75 multiplied by 12, anybody? Sorry? Oh, sorry, you're right. My fault. It's 0.2, because the xt is 0.2. Yeah. Is it 15? Okay.
75.
Okay. 15, okay. So 15 centimeters cubed per second. If you're looking to try another one like this, I might try to get you to do it now. I think it's the 2013 paper 1. You want to have a look at it. And it's going to be question A to E. Give a look at that one there.